Hi everyone. Today I'm going to talk about choosing the right oscilloscope. So there are many different scopes to choose from, and of course looking online this can get very confusing because there's tablet scopes and there's ones that are the size of little phones now, and there's the older scopes, there's the newer scopes, analog, digital, all these different things. And I'm also going to talk about a few things to get you going on using the scope. Just a few simple little things, and they're surprisingly easy to use. A lot of people look at the oscilloscope as some big mystical device, when really it's quite a simple device. And if you keep these few little tips that I'm going to give you in mind, using your scope will be an absolute breeze. So let's get started. One of the first things I'd like to address is many people see this scope on my channel and they say, Paul, it's a really nice looking scope, but there's no way I could afford anything like that. Well, I got this for next to nothing because it was broken. It didn't do anything when I got this thing, so I spent a lot of time in it and repaired it. It had just a whole barrage of issues. Now, purchasing something like this, if you're not familiar with working on equipment like this, you would probably want to get one that's working, I would say, relatively well. Say it needs a new battery or something like that. That's not too big of a deal. In fact, you can even rebuild your own battery packs for these things. These things aren't all that incredibly expensive for what they do. 200 megahertz, 2.5 gigasamples per second. These things sell, working in relatively good condition on the market right now for about $1,000 or something like that. And, if it doesn't miss bars, it's not missing rows, all right? And, the battery's holding a charge and nobody's fried the inputs. And it's an exceptional scope to have just for a few reasons. It has isolated inputs, which is very, very nice to have. Of course, it has a battery pack in it. The thing is mobile. You can stand it up. You can even hang it up. It has this thing here so you can hang it while you're working on things. It has a DMM inside. It has all sorts of features inside that are very desirable for, field work, or if you just want to use this on your bench, that's pretty much a one type of thing. You can use it for everything. It doesn't test capacitors and things like that, pretty standard. But, it's a pretty good all-around scope. Now, there's lots of scopes, you can even find them on Amazon, lots of scopes that look like this that have very similar functions. The catch is when you're buying a new scope, nowadays, scopes are so reasonable, I very strongly suggest that you do not go below 100 megahertz, even for general use. All right, if you're an audio person, still buy that 100 megahertz scope, right? Because, one day you might be looking at a fast square wave. All right, you want to look at rise and fall times. You can look at relatively fast rise and fall times with a 100 megahertz scope. Another thing you want to keep in mind, as I mentioned in the previous video, is for every 100 megahertz, you would want 1 gigasample per second. Don't go below that. All right, so don't cut yourself short there. So 100 megahertz, 1 gigasample per second. 200 megahertz, 2 gigasamples per second. 1 gigahertz, 10 gigasamples per second is really what you want. That's how it should be. So just keep that in mind if you're going to be purchasing a scope. Again, these things can be had for relatively cheap. You just have to look around. These are being replaced right now. This is a relatively old model now. Fluke has the new model. They don't have a fan inside that gets noisy, and the batteries are different. These things are relatively hard on batteries. There's a bunch of downfalls with the 199C, but as long as you're any technician that owns one of these things could very easily take care of it. And obviously these things are, 99% of the time in a technician's hands, right? So, relatively easy to take care of. I recently bought a brand new battery for this thing just from a local battery person. They had one on the shelf, and you just plug it in and away you go. And they're, relatively decent priced. The next one I may make myself, so I might do that and I'll share that process with you. Again, great scope meter. If you look around, you can find these for a decent price. Now, Siglent, Regal, they all make really good scopes. Again, just as I say, 2 channels would be the minimum that you would want. You would want 100 megahertz minimum, and 1 gigasample per second. And, you're kind of off to the races if you're just doing general work. Now, again, buyer beware. If you're going to be working on 400 megahertz stuff, you don't want a 100 megahertz scope, right? You want to have something that's going to exceed 400 megahertz, right? So, just once you get up into that range, you're starting to get into high-end RF stuff, the prices of scopes do go up. Now, if you're just looking at, sine waves and things like that, and you want to verify signals and so on and so forth, You can get away with an older scope. You can get away with an older, 500 megahertz scope. I have my Wave Runner LT344, which is right over here. I'll show you these scopes here in just a moment as well. I picked up for next to nothing again. It's 500 megahertz and it's an old scope, so it's only 500 megasamples a second. But I'm not too worried about that because I'm basically only looking at sine waves with that, right? And it has 4 channels and it's not running on Windows like this thing is in front of me. So this Tektronix scope here that you see right here, you've seen in some of my videos before. If you see one of these things in my videos, don't think that you should be running out and getting anything like this. This scope, I have a real love-hate relationship with this thing. I've had this thing apart probably 10 times, and it's a bear to keep going. So they have basically some, I guess you could call it non-volatile RAM. Let's call it like that. And I believe it's called a power cap inside this thing. And before I got it, the battery went dead on the power cap. And the person that had it before me, I guess, reflashed that. And he got it working again. If that power cap goes bad inside this thing, it's a brick. And, I've thankfully, I've got a lot of information on this now. There's a lot of people that have read the information out of that and then stored it, and then they provide it now. And, if it was to happen again, I would probably easily get it going again. The thing is that this thing has so many intermittents. It's been a bear. This thing has to have 1,000 screws in the case, of course, exaggerating slightly, but it takes 10 minutes to get it apart. No exaggerations, just so many screws. And it'll work great for a week. You think everything's going fine. You turn the thing on and the screen has got jumbled information on it. And you're like, what? So you got to let it go through its entire boot cycle, and because you don't want to shut it off, because you don't want to corrupt the hard drive, which has happened already. And it's cleaned its own drive. So I have backup drives for this thing that I can just take that drive out, plug another one in if I need to service it. And I have a couple sacrificial drives that have the same info on them. So from an earlier date, so I can plug another drive in if it tries to wipe its own drive again. A stick of RAM went dead, and it corrupted the drive, and it just did nothing. The amount of issues I've had with this has been above and beyond. So don't think that if you see this TDS 7104, this is some behind the scenes information for you. This thing is not one of Tektronix's nicer scopes. I can tell you that. So it's been a bear to keep running. I think it still runs. I'll turn it on and I'll show you what it goes through. I believe this thing is on Windows 95. A lot of these older, I have a couple pieces of equipment that are on Windows 95, 98. I think one is on XP. My Spectrum Analyzer that's up here, my Aeroflex Spectrum Analyzer is on XP. So it takes just a few moments to boot. Who cares about the operating system, right? I'm using it for an oscilloscope. So I'm not worried about changing that out, things like that. So I have had to change the switch here. This here had some flex wire in it. In fact, I think I still may have it. This is another real problem. Hold on one second. With these older tech scopes. Same with the TDS series. Here it is. I just recently did this, and it's still in my garbage. So here it is. It's one of these things. Zoom on in. And you can see just from the wire bending in the chassis, that isn't even me doing this, just bending in the chassis. I touched this with a soldering iron just for the fun of it. They crack. And on this side here, there's a little a red and green LED. And then when you push the soft button on the front here, zoom this back out again. When you push this button here, it has 2 little carbon contacts on it that touch this and turn the thing on. Well, it wouldn't turn on anymore because this. And it's not, it's just been bent. And I guess it just decided to go away. So at any rate, that was done. So what I did is I actually put a push button behind here. And I glued it to the face and ran some wires in the back and got rid of the red-green LED. And this had been cracked from being pushed so many times. So I just put a little bit of felt marker on that. And that kind of stands out from the face now. There's some super glue on the top of this to hold it. And it works really good. Click, click, nice and positive. Click, click, turn on and turn off. So anyways, these things are a real problem with all the older tech stuff, all the TDS series, the older tech stuff, they all have these in, which I've had to replace. My TDS 420, which is behind me here, I also replaced this with a push button because for some reason it failed as well. So The older tech stuff is something fantastic. This newer tech stuff from this kind of era is, I guess you could say, almost designed with a life intent. I guess you could say a certain amount of life. The Keurig coffee maker that I just repaired, that took an incredible amount of time to do, and that was basically just done to show everyone that you can keep a piece of plastic out of the landfill. So those things, so many of those things go into the landfill because of these issues. You can read the comments in that in the video, and you'll see how many of those Keurigs actually end up there. It's just amazing. Probably as many Keurig coffee makers end up in the landfill almost as the K-Cups do. So, and just so you know, you can have the refillable K-Cups. You don't need to use the disposable ones. You can have single cups of coffee and prepare a bunch of them and ready to go so you don't have waste. It's actually, believe it or not, using the Keurig, if it would last, using the Keurig is actually more economically viable than using a coffee maker, because you have a disposable coffee filter and you usually have to put a whole bunch of coffee in to brew a pot. If you use the washable K-Cup, you just put in as much coffee as you need and away you go. You have your coffee, and there's just that little bit of waste instead of that in the paper and everything. So it all depends on the way you look at the Keurig. So I know a lot of people say that, oh, those are so wasteful. No, it just depends on how you use it. And if you use it sensibly, they're not wasteful at all. In fact, they're more conservative than an actual regular coffee maker with a paper coffee filter. At any rate, so anyways, back to the scopes. So those are the guidelines for an oscilloscope. If you're going to look for a scope for general purpose use, say you're just looking for one that for everyday kind of use, you don't really have any type of intent in mind. Say you know you're not going to 400 megahertz, or you know you're not going to 200 megahertz or something like that. Go with the 100 megahertz as a baseline. 100 megahertz, 1 gigasample per second. Again, Siglent, Rigol. There's so many of them now. Agilent, or Keysight, I should say. They all make really good stuff. They all really do. There's so many aftermarket ones. Okay, this is just me. You see these little tablet scopes? Read carefully before you are tempted to buy a tablet scope, because a lot of the times the specs on those scopes are really quite horrible. You've seen me use that TPI. It has a little scope on the screen. That's more novelty than anything. If you want to probe something and just randomly see some AC or something on a signal and it's low frequency, the TPI is absolutely fine. If you want an actual oscilloscope, I would say you need something with a BNC input and a ×10 probe, and again the aforementioned specs there. So just keep that in mind. I'll show you this thing here. I'll give you an example of what these techs do, these old Tektronix TDS7104, just in case you've been thinking of trying to get one. And I'll give you an example of some of the other older scopes here that I have. You can get these for really cheap. This, again, I wouldn't purchase. The Wave Runner is great. I'll show you that one as well. And just some used scopes that you can pick up for at online auctions for next to nothing. Okay, I hope this is an accurate enough angle to show. You can see all the reflections in the screen here. Kind of went off to the side. It's a little bit dusty. That's a burn from solder accidentally getting flicked on the touch screen. That won't come off. That's in there permanently now. If you don't have bright light on it, and when the screen comes on, it virtually disappears. That was one thing that was kind of unfortunate. I did this during the DeForest Crosley restoration last year. I moved the iron quickly and a piece of solder landed on the screen, and of course that was it. So you've been seeing a piece of paper over this ever since then, just to protect it. Most screens that wouldn't even bother, you flick and it comes right off. This, it just did something pretty bad. Also, if you have something like this with these touch screens on it with this soft plastic layer, I've also noticed that if you just put just a touch of furniture that they have this beeswax compound, if you just put a touch of it on there and blend it, you can't even see it at all ever, and it doesn't glare or anything, and it actually completely gets rid of it. It's almost like putting a bit of a clear on there, and it doesn't hurt the screen. But this is dry right now. This was actually removed and taken out of the lab for quite some time because I just couldn't get the thing to be dependable enough to use. So anyways, let's see if the thing starts this time. It should, hopefully. So there it is. Hopefully you can see that. Zoom into that just a little more. So it takes just a few seconds to boot. The panel goes off, so the lighting on the panel goes off, and while it boots, and there's a code inside. Let's see if I can shut that off. There's a bunch of codes flashing on a board on a 7-segment display inside that tell you what's happening through the boot cycle if the thing fails. So, like, don't get me wrong, when it works, it's a fantastic scope. That's the reason it's on the bench. It's just keeping the thing going, which is a bit of a pain. It has 6 large computer fans on this side. That's what you're listening to right now. And they get ramped up, and so here we go. It's through that cycle already. It's a really old operating system, but not a big deal, as you can see, right? But it moves quickly. There's a solid-state IDE in here. I have a solid-state IDE drive in here now, so it's there's no more mechanical drive. The backups are mechanical. So you'll hear it test the inputs here in just a second. And there we are, we're back into the scope now. And this is pretty much how it stays. You can see something zip off down to the bottom here in just a second. And there it goes. And I usually put resolution down to 500 so I get a finer line. And, you know, get rid of this. And then, of course, I'm into my scope screen, and it's ready to go at this point. So, you know, what does it take? A few moments to boot up. Now, when it's running, it's a fantastic scope. It has, you know, tons and tons of features. And it really does work quite good. And of course, you can get these things now on, you know, auctions, government auctions, for almost nothing. So, you know, of course, you know, if they don't power up, there are a little bit of work to do. You'll hear the fans ramp down in a second here. So I don't know if you can hear this. It'll happen in just a moment. So I don't know why it does this, but if it takes too long, I'll just cut to the part where it does. There it is. So yeah, there's 6 big computer fans in there, right, pulling air through the device, you know, along the acquisition area and the, you know, through all the boards and everything. And then there's the CPU fan because it's got a motherboard from a computer in here and everything, right? So there's lots of fan work going on. It's got a monster power supply inside. So when they do work well. So shut it off. So that's that scope there. So I'll move this over to the Wave Runner, and I'll show you that one. That can be had for super cheap, and if you're looking at just sine waves and, you know, things like that, yeah, that would work just fine as well. It's 4 channels, and I picked that up not long ago for, well, next to nothing again. So I'll just move the camera, and I'll show you that one. Here's the LT344. Now this one here is the 500 megahertz. At 500 megasamples per second, and I really like using this scope. It's a great scope. Fan's a little bit noisy on this one, but and it also does take the screen just a little bit of time to come to life because of the old backlight in there. So what I'm going to do is turn the lights off here, and I'll zoom into the screen just a little bit. We're kind of off to the side, and it does make viewing this just a little bit tougher. Doesn't look all that incredibly bright. It's also because of the angle I'm on here. So what I'll do is I'll just lift the camera up a touch and get that in there like so. Keeping all the reflections and everything off the screen all at once is a bit of a challenge here. So to me, this is nice and bright. It's just because of, again, the angle that the camera's on and everything like that. This will get brighter. It's just, again, the backlighting. And then, of course, I have the graticule turned down so I can see the signal nicely on here. So there's a lot of really nice functions with this scope. It is 4 channels, and here it goes through its auto cal and you know, things like that. So lots of on-screen, I guess you could say, information here. And it is a really, really nice scope. So very easy to use. It is relatively intuitive. I would say more so than, you know, say something from Stanford Research or something like that. It is, it is relatively good. The user interface is not as good as a Tektronix piece of gear or anything like that. A lot of the newer gear, the user interface is actually a little bit nicer to use, but it is still very usable. Again, if you're just looking at sine waves, and if you're looking at amplitude levels, at say you're working on oscillators and things like that, very, very good. 500 megasamples is absolutely fine for something like that. If you're looking at really, really fast signals, and you're wanting to do digital work, of course, stick to that 100 megahertz, 1 gigasample per second kind of rule. So again, if you want to have 1 gigahertz, you're going to be looking at 10 gigasamples per second, something like that. So you just want to keep that in mind. It's just, again, it depends on what you're going to it just depends on what you're working on, right? One of the big confusions about scope inputs is AC or DC input. So, and this is where people get caught trying to look at very, very sensitive signals. So most of these scopes, because nowadays everybody's doing digital work, I find they just default to DC. So we go to here, you can see input coupling is on DC. And if you hit auto or anything like that, it just automatically defaults to the DC coupling. Now, DC coupling is great if you want to use the meter itself and you're wanting to read battery voltages or something like that. So we can go to scope, we can go reading 1, and I'll go here and we can go volts DC, and we can go OK. So this will give us volts DC. Now, if I put this on to automatic, it is my trigger is on. This is another thing I'll talk about here is the trigger. So I'm going to go trigger options, and I'm going to go automatic, and I will go up here and go enter again, and that'll get it off of low frequency, and it's on auto level, and it'll just automatically randomly search now. So say I take a 9-volt battery and I want to read a 9-volt battery. I can read a 9-volt battery with this. It'll automatically go to the level and give me a DC level here in just a moment. Right? So battery's roughly 9 volts, right? So you can see it's looking for a signal there. It's not incredibly fast, but it will find it. So 8.95 volts. Now, the thing is, you'll see that it's gone up the screen and it's showing up here because, of course, we're comparing it to a baseline here, and you can see the volts per division. So I'll go back to this again. All right. So you can see here roughly 5 volts per division, right? So, we're at 5 and then 10, right? So this would be 5 and 10, and it's just below that. So we're, roughly 9 volts, right? Now, that's the DC level. That's what DC looks like on a scope compared to the baseline. A is the baseline here, right? Now, if you're looking, say you're looking at an old radio and you have a power supply and there's ripple on it, you can't be using the DC setting, because what's going to happen is it's going to go to say the B plus in the radio is 200 volts or something like that. It's going to read 200 volts DC on there, and you're going to basically not be able to view the ripple because you're looking at the DC level, right? This is going to go all the way up to 200 volts. So basically what you need to do for something like that is go back to here, and I'll go input A, and you need to go to AC coupling. Now watch what happens with this when I go to AC coupling, right? It drops it right back down to the line down here, right? And now we can look at very, very sensitive signals because we don't have that DC offset happening. So we don't need to look for that very small amount of ripple on a very high DC voltage. And that's where AC is. So basically what this is doing is putting a capacitor in line inside the scope. And what that does is that is blocking DC right now, so we can really narrow into small signals. So we would, very easily be able to narrow into the ripple on a power supply, say in a radio, if we wanted to look at that ripple. A lot of the times when you're using a scope, you'll get a signal that looks like this if the trigger isn't in the right spot. So basically what the trigger does is it allows the scope to take what's coming in and display it nice and steady on the screen. So it's basically allowing the scope to trigger on the signal. So what we can do is move this little trigger basically just right into the area, and what it's going to do is just lock on it. Now, you can move the trigger all over the portion of the actual incoming signal. If there's a portion that is, I guess you could say, a little bit more consistent than the other, you might get a more steadier display. This is a nice steady signal, so it just triggers on this nice and easy. Say you're looking at a signal like this. This is now reading 3.6 volts peak. So that's 3.6 volts peak on this. And that's from the line to the peak of the signal, right? And if you want to look at rise time and fall time, so you want to see how long it takes for this signal to turn on, that's relatively simple as well. All you would have to do is, you can, if you have an analog scope, you can move the time base along and then use the boxes on the screen to figure that out. If you have a digital scope, it's usually, quite a bit easier than that. So what we'll do is we'll go to A, and we're going to go actually scope, and we'll go say reading 2. I'll change this. This is a 1 kilohertz signal right now. And what I'll do is I'll go to rise time, which would be over here, and go enter, and then go close. And then what I want to do is I want to move this so I can actually see the rise there. So basically I'm looking for a bit of a tilt, at least enough of a tilt so that the signal is going to, it's going to be able to pick the measurement up. So what I'm going to do is go like this, turn this up, and pretty soon we're going to get a rise time measurement, and there it is. So you can see the rise time is about 120 nanoseconds, 130 nanoseconds, something like that. There's a bit of noise on it. And that's telling you how long it's taking the signal to go from the baseline to fully turned on. It's about 120 nanoseconds, something like that. That's the amount of time it's taking. You do the same thing for the fall time as well to see how long it takes for the signal to shut off. When you're working with MOSFETs and things like that, the amount of time it takes to turn the FET on is very crucial, because you want that FET to turn on extremely fast to keep it out of any type of linear region. So the quicker you can turn it on and the quicker you can turn it off means less heat in the device, especially with a very low on resistance. So you want to keep that thing out of being ramped up slowly. You want a very, very fast signal. And of course, again, that it all depends on the driving and what type of what they're driving the FET with and everything like that, right? So anyways, that's how you look at rise time. And then, of course, you can look at fall time the same way. It's just the other portion of the signal. It'll tell you how long it takes for the signal to go from on to completely off. Each one of those is very important. So you need to make sure that if you're dealing with switch mode power supplies and things like that, it is nice and quick. You want it as quick as possible. Reason being is, again, the FET will get hot. And if it is slow, if it's a slow rising signal, the FET will burn out very, very quickly. You get excessive heating in the components. This is the reason switch mode power supplies make so much noise, right? Because there's such a fast on and off. They create lots of harmonics, nice square wave. They're driven with nice square waves. And of course, square waves are harmonically rich, right? So there you go. There's a few other things to know about oscilloscopes. They're extremely easy to use. Basically, you just want to fiddle around with the thing for a while. And analog scope, same thing. You can do all of this on an analog oscilloscope. In fact, I use my old Type 547s all the time for low noise measurement. And I'm continually using the boxes to figure out rise and fall time and all sorts of things. So, it just depends on what you want to do. AC-DC coupling, same thing with an analog scope and using the time base, exactly the same thing as this. It's just that this thing does a lot of the thinking for you. Whereas, the older analog scopes, you have to use a little bit more brain power, kind of the equivalent to, doing math on a piece of paper or using a calculator, right? Same kind of idea. If you're going to purchase a used oscilloscope, you should always test the inputs. A lot of inexperienced people, what they do is they'll use a ×1 probe, they'll overload the input and then burn things out. And if you buy a scope like this and it has a burnt out input, you're going to be dealing with a little bit of money. So you always want to make sure that the inputs are working okay. Now, a lot of the times, unless they have a calibrated source, it is tough to test the input. So you would want to have the scope probe, say a ×10 probe on it. Most of the time you're going to be using a ×10 probe. And of course you want to set the math in the scope so that it reads correctly as well. A lot of the tech scopes, if you plug the probe in, it'll actually sense that it's a ×10 probe and change the math automatically, which is kind of nice. But for something like this, you need to go in there and you need to set this all up by yourself. At any rate, so what you want to do is you want to make sure that the input is actually working. So if you're going to buy this from somebody and you don't know what's going on, either you want to bring your own signal source and you want to test it out, make sure that both the channels are working. One way that works somewhat if you don't really have a calibrated signal source with you, but you can kind of tell, is, use both channels. And if both channels display the same thing, there's a really good chance that they're both working okay. If one is a lot different than the other on the same setting, the one channel's probably been damaged. So that's one way of telling without having I guess you could say, a calibrated signal source. It's not dependable all the time because maybe somebody's damaged both channels the same way. Not common, but it does happen like that. So that's one of the things. If you're going to be buying anything used, you want to make sure that it's tested correctly, because blown inputs on a scope are sometimes relatively difficult to fix. And if they're using any type of an ASIC in the front end, you're dealing with issues there as well. So you can see this is on DC right now, right? So you can see if I go here and you can see coupling is on DC. So what's going to happen if I press AC? Well, this should shift down to the center, right? Because this is going to be capacitively coupled, okay? So you can see that. There we go. So now it's down to the center. I'm going to have to move the trigger. So I'll go to trigger here and move the trigger down, and it'll trigger on that. So there you go. You can see how that moves to the center because now it's, coupled with a capacitor onto the input. We're not actually looking at this on a DC scale where this would be 0 volts, and then of course, going up from there, right? And that allows you to look at very small signals. So you can see how that shifts that on the screen. So keep in mind, most scopes, when you do click to AC coupling, it's placing a capacitor in line. It's blocking the DC in most applications at any rate. So a few things to keep in mind if you're going to be looking for a used scope. If you buy a brand new scope, the brand new scopes are very relatively, I guess you should say very reasonably priced now. So you can get a 100 megahertz, 1 gigasample scope for, a really good price. And there's so many different makes and models. It's not like way back in the old days when, 100 megahertz was like, buying a 100 megahertz scope was, you're going to the bank big time to go buy something like that. Prices of oscilloscopes have come down so much in the last years. It's really quite incredible. So yeah, it depends on what you're looking for. If you're if you're prepared to work on something, you by all means buy something used. But if you're new to the game and you just want a piece of equipment to work right out of the box, I would strongly suggest that you buy something new. And of course, buy the frequency that you're going to be working with. So if you think you're going to be working at 1 gigahertz, well, you're going to need a 1 gigahertz scope or higher. Usually I like to overshoot a little bit. So most people, even I find myself, I rarely go to 200 megahertz, right? So, looking at sine waves and things like that. So again, it just depends on what you're looking at. Of course, if you want to look at fast rising signals, of course, you're going to want something that's got, decent vertical bandwidth and things like that as well, right? So I hope this video was a benefit to you. You can let me know in the comments below. If you'd like me to go into some more of the details of a scope, I could talk about what's inside scopes for an incredibly long time. There's so many different features and functions, but the functions that I've showed you are the easiest just to get you going. So anyways, if you enjoyed this, let me know. And if you'd like me to add anything to this, just leave it in the comments below. And if you enjoyed the video, don't forget to tap the heart symbol. I'll talk to all of you very soon. Bye for now.